Good day, my name is Darryl Williams. I'm the founder of Surface Measurement Systems. I'm going to speak to you for the next couple of minutes about a technique that I've been involved with now for about 20 years. It's a technique called dynamic vapor sorption. A few of you may know about it already and maybe even use it, but it's still a technique that not everyone knows about. The technique was developed by myself in conjunction with Pfizer about 20 years ago. Pfizer in the UK wanted to characterise many of their solid state materials, their excipients, their drugs, their tablets, and they particularly wanted to know about the amount of water inside a material at a particular humidity. So essentially at that time I built a technique for them called dynamic vapor sorption. So it's a gravimetric technique which allows us to work out how much water is kept inside a material as a function of the outside relative humidity. In fact, the technique is quite similar to thermogravimetric analysis, a technique many of you may already know about. In TGA, we look at the amount of mass of a sample as a function of temperature. The DVS technique is similar. For DVS, we measure the amount of mass change in a sample as we change the humidity, and normally we keep the temperature constant. So mass change as a function of humidity allows us to learn a lot of information about a solid. We can learn about the equilibrium moisture content within the material, in other words, the percentage mass change due to moisture adsorption or absorption into a material. And we can also learn about the kinetics, how fast moisture goes into a material or comes out of a material. And having this sort of information is very important. We can learn about the stability of a material, we can learn about hydration, diffusion, we can learn about the way hydrates form, we can learn many properties that are important for understanding the manufacturing, the development, and also the stability of products involving water and other solid state material forms. You may be wondering what was done before the invention of the DVS method. Well, of course, there was a manual technique for measuring the amount of water in a solid that was used before the DVS method was invented. So you typically take a few grams of sample, you put it in a petri dish, and you put it in a constant humidity environment and you'd wait. Quite a few days, in fact, maybe a week or a month. So the DVS technique, when it came along, had a number of advantages of these older manual techniques. They were typically 10 to 100 times faster, 10 to 100 times more accurate, and typically 10 to 100 times less sample. So these were major benefits. The benefits which meant the DVS method became very popular in laboratories throughout the world, and has now become a standard technique in the pharmaceutical industry, and is fast becoming a standard research technique in many other areas, including foods, biomaterials, catalysts, polymers, personal care products. Let me explain how the DVS method works practically. We start by taking a small amount of the sample we want to study. Typically quite a small amount of material, about 10 milligrams, which is the size of rather a large match head. And that's all the material we need to do a full characterization of our material. We'll take that material, put it in a small glass pan, and we'll attach that to a very sensitive microbalance. In the DVS instruments, we use microbalances that have a resolution of 0.1 microgram, and they can measure mass changes up to 1 gram. So we're able to measure very small changes in sample mass. And that small sample will be exposed at a constant temperature to a user-selected humidity. So we'll select a humidity and we'll measure the way the mass changes. Sometimes the mass will decrease as the sample gives up water, and sometimes the sample will actually increase in mass as the humidity increases. And from the amount of water taken up by the sample and the rate at which it takes up, we can learn a lot of information about the way the material is going to behave. The DVS method is an important way for characterising solid state materials, which allows us to learn a lot more about their properties and their performance. And that can help us in R&D and manufacturing and in product development. And it's now used by over 1,000 laboratories in industry and academia throughout the world.